Myself, Rajesh Shah, Assistant Professor, Mechanical Engineering Department, College of Engineering, Muttatara. I welcome all the participants to the FDP on Green Energy Solutions, Building a Sustainable Carbon Neutral World. The program conducted by Mechanical Engineering Department, College of Engineering, Muttatara. Today's topic is Green Energy Solutions for Ground Handling of Civilian and Military Aircraft, and it is chaired by Sreeja ma'am. Sreeja K, our presenter today, is the Chief Project Manager of Panchatejas Innovations Private Limited, Bangalore, and she has 17 years experience with the Hindustan Aeronautics Limited, and she's an expert in manufacturing process and design for military aircraft. Also, she closely worked with customers like Boeing and Airbus. So I would like to welcome Sreeja ma'am to this session. Thank you.
Thank you. Yeah, thank you, Rajesh sir, and a warm welcome to you all. Thank you for this warm introduction about me. I'm Sreeja. I work for Panchatejas Innovations Private Limited, Bangalore. Last year I joined this company, and before that I was working with Hindustan Aeronautics Limited at Bangalore, as told by Rajesh sir. So today there's a small change in the topic. The topic given is like what was displayed there was like green energy solution for ground handling of civilian and military aircraft. There is one catch, like military aircraft, military data is not available. Actually, maybe because of the security reasons or other concerns, military data are not readily available. So today we will be discussing on sustainable aviation on a broad manner, on the civil aviation front, and even ground handling equipment pertaining to civil aviation. Let me share the presentation. Give me a moment. Yeah, so today we'll be discussing on sustainable aviation and green energy solution for ground handling in general, basically pertaining to civil aviation. So what I'll be covering today, I'll briefly explain. It's an intro into global sustainability. You might be knowing all these things, but still we'll have a rush through, and we'll talk about aviation sector statistics. Also, we'll talk about what are the sustainability targets and strategies globally set and adopted, and we'll have a brief discussion on SAF. SAF is Sustainable Aviation Fuel. We'll have a brief discussion. So we'll also discuss about the challenges what we face in aviation, maintaining sustainability in aviation, and we'll talk about the ground handling operations. What are the various ground handling operations? What are the ground support equipments used in aviation? What are the sustainability strategies in ground support equipments, and what are the challenges? So basically these two things. One is the aviation sector, one is the ground handling sector area. Both we'll be discussing today. So to start with, yes, sustainability. Sustainability is critical now. It is no more an option. It is a necessity. Why? Because the world is developing. Economies are emerging. Technologies are advancing. And as all these things happen, even population is rising. And as all these things happen, the energy is a must. Like there's a lot of needs of energy. And as energy consumption increases, obviously there is a emission rise, because we generally depend on fossil fuels most of the time. So that is the reason why if you don't keep a check on this energy consumption, and that's fossil fuel energy consumption, it's going to give a drastic output on the carbon dioxide emission, and the results are going to be catastrophic. Even it is said that if we don't check the emissions now, the global temperature can rise up to 3.1 degrees by the end of this century. It's a report which stated it can rise up to 3.1 degrees. Imagine what is the fate if the temperature rises up to 3.1 degree. So it's going to have a catastrophic effect on the Earth, planet Earth. The vitality of the Earth will be lost. So this is the reason why we are here. We are discussing about sustainability. And in the Paris Agreement, it was agreed. I hope you are aware of the Paris Agreement. It's a part of COP21 in 2015. It was agreed to limit the temperature rise below 2 degrees. And all the countries are supposed to work towards attaining 1.5 degrees. The one thing alarming here is, like, as of 2024, that's last year, the global temperature has risen above the global temperature has risen above 1.55 degrees, like approximately 1.55 degrees, which is well above the set 1.5 degree increase in temperature. So it's alarming, quite alarming. And that's why this 2024 is a significant milestone to the first year which has surpassed this 1.5 degree threshold. And now we have been witnessing so many extreme weather events, even all over the world, even in India, even in all local regions, we have been witnessing so many weather events which are extreme, like unusual heavy rainfall, flooding, unexpected landslides, hurricanes, typhoons, dry region experiencing floods, droughts, glaciers melting, etc. And even heat wave, you can see North India is suffering because of heat waves. Sometimes the temperature exceeding 47 degrees Celsius. So what are all these? These are the constant reminders that we need to accelerate our action. We need to take action immediately, else the results are not so good. So, and these things are not going to stop. These extreme weather events frequencies are going to increase in the years to come, the days to come. So it's a caution for all of us. And before going to the aviation area, let me introduce, maybe if you might be aware, but I'll brush through all these things, which are the global terminologies used in relation with the climate change. So first one is the UNFCCC. It's the United Nations Framework Convention on Climate Change. It was set up in 1992. It's the major global body. It's a global body which sets framework. It's for the climate change, what action needs to be taken. It fights climate change. It sets framework. It supports international agreements and promote financial and technical support. And more than that, it organizes the annual COPs. You might be aware that last year we had in 2024 November, we had a COP 29 at Baku, Azerbaijan. And every year before that, like we have been having this conference of parties. COP is nothing else but the conference of parties. So we'll see what it is in coming slides. And then next is the IPCC. This is again one of the important organization, Intergovernmental Panel on Climate Change. It was set up in 1988. It's again a UN body, and it's a scientific body that assesses the climate change. Like it's a body which gives us, which assesses climate change year by year, and it publishes assessment report and which forms an input to the COP discussions and many other climate change discussions. And it also assesses the impact of climate change and gives response strategies. Now, when it comes to aviation sector, we have many organizations, but the main two are the ICAO, which is International Civil Aviation Organization. It's again a United Nations it's a part of United Nations organization, and it basically focuses on the regulations of international civil aviation. As the name indicates, International Civil Aviation Organization. It sets up the framework for international civil aviation. And it's a public sector organization, and the members are the countries, like various countries are member to this ICAO. And the main focus of ICAO is safety standards, air traffic management, and environmental policies. With this basic focus, this ICAO has been set up. Next is IATA. IATA is International Air Transport Association. It's a trade association of the world airlines. And it represents the interest, as every trade association works, it also represents the interest of the airline industry. It includes the airlines, cargo operators, and travel agencies. It's a private sector organization, but work hand in hand with ICAO and other global organizations. Now, yeah, Conference of Parties. Conference of Parties, COP, it's like a global conference where various government leaders, policymakers, scientists, etc., maybe even government representatives, they will be meeting to discuss on how to reduce emissions and how to adapt climate impact, adapt to the climatic impacts that happen. So climatic impacts in the sense adaptation to climate change means sometimes we may have to build in resilient infrastructures. Sometimes we have to set up early warning systems for the natural disasters that happen. So all these climatic conditions, sorry, one second. So this conference of parties basically discuss on this adaptation to climate changes, as well as reduction to emissions. Now the COP21, which is Paris Agreement 2015, it has been the major COP, one of the major COP, because in this COP, a consensus was reached where the global emission would be limited to 2 degrees Celsius, with efforts would be maintained to maintain it below 1.5 degrees Celsius. And COP29, as you are aware, it was done last year, where it was supposed to be a finance COP where more financial funding was supposed to come, but unfortunately, it didn't happen. Only $300 billion were agreed by developed countries to sustain as a climate finance for the developing countries. Even though developing countries were asking for $1.3 trillion, but unfortunately that couldn't happen. So it's still a very less amount that has been agreed to be funded by developing countries, that too by 2035, again in another 10 years. So nationally determined contribution, this is NDCs. So this has been again introduced in Paris Agreement in 2015. So every country has to submit nationally determined contributions, which are like what are their action plans. Like every country has to decide what are their action plans to reduce their emissions, as well as adaptation to climate change, what are their action plans. In these sets, they have to give what action would be taken in these areas. And based on these NDCs, the SFC, that is the Standing Financial Committee, will be deciding what finance is required for that particular country for sustaining climate change. So again, SCF is a United Nations body which assess the financial needs of the developing countries based on their NDCs. And as per this SCF estimation, the financial need stands between $455 billion to $584 billion. That took as of now. It's a current estimation. Annual requirement is $455 billion to $584 billion for to sustain our goal of limiting our temperature rise up to 1.5 degrees Celsius. But unfortunately, in the last COP, it was hardly $300 billion was agreed, as I mentioned, that too by 2035. So we can see a large gap in the finance funding being the major concern for the climate change, fighting climate change to attain sustainability. There is a lacuna here. And carbon credit, yes, carbon credit, we all know, like they are tradable certificates which can be used for trading. Carbon credits, yes, these are tradable certificates. And one carbon credit is equal to 1 metric ton of carbon dioxide. Like what happens here is there is a cap fixed for every company, every organization, how much emission they can do, they can produce, how much emission can be produced. And if a company wants to pollute more than this emission, they need to buy carbon credits. So who will be selling the carbon credits? The companies or the organizations who use more renewable energy and who takes part in like afforestation programs or preservation of existing forest, etc. Like where there is a sustained effort for towards containing this global emission, those companies can produce, and whose emission are considerably less than the capped figure. They can have this carbon credit in hand, and they can sell this carbon credit at a cost to this companies who require this carbon credit, like who want to sustain this. So this is a method towards achieving carbon neutrality, and this is a market-based strategy. Carbon credit is a market-based strategy. Okay, let's talk about aviation sector. Aviation sector, coming to the aviation sector, yes, why aviation sector is important? Because you should see that 2.5% of the globe's total emission. That's a report published by IPCC. 2.5% of the globe's total emission, carbon dioxide emission, is from aviation sector. So 2.5%, that too, like we know that everybody does not fly on the earth, like on the world. Hardly 10% of the people in the world fly as of now. But as they get more richer, as connectivity increases, obviously there are going to be more flights. People are going to fly. In such a scenario, with the current 10% people flying, if the emission is 2.5%, we can imagine if more people start flying, what will be the emission. So this is why this is alarming. This is said to be alarming actually. And there's a rapid growth in aviation sector. As I told you, more and more people are preferring to fly. People who want to travel earlier, if 20 years back, if people wanted to travel from Cochin to Delhi, they mostly they would have chosen like train travel. But nowadays, people value their time. The tickets are available at comparatively lesser rate. They choose aviation, like they choose flight. So there is a rapid growth happening in aviation sector, and as the rapid growth happens, definitely there are faster growth in emissions also. And if you compare the other transport media like rail, road, or shipping, aviation sector is emitting more. It is a high carbon intensity area. Why it is called high carbon intensity area? Per unit of fuel, the amount of carbon emitted is very high compared to any other area. So that's why aviation is under radar. Aviation should be kept under radar. Now, this is a ICAO report. There are 7 sectors which add to global GHG product, emission, like greenhouse gas emission. Basically, they are energy supply sector, industry sector, forestry sector, agriculture sector, transport sector, building sector, and water sector. So in these 7 sectors, the transport sector is almost contributing 13% to global GHG. So when we again split up this 13% of transport sector, the main contributor is obviously the road, because number of vehicles are more. Road transport, it is contributing to almost 74%. And coming to aviation, it is 13% in the whole transport sector. Now, in this 13%, global aviation, like if you say domestic aviation is contributing to 35%, and international aviation is contributing to 65% of aviation. So we can say that international aviation accounts for about 1.3% of total global carbon dioxide emissions. So this is a report published by ICAO. So this can be like, this is almost 190 to 95% realistic. Now coming to the emission in terms of quantifiable emissions, we can see the global carbon dioxide emission only from aviation. This is a chart from 1940 to 2019. From 1940, it was almost nearing 0 tons. But you can see in 1990 what has happened. 1990 it has reached 0.5 billion tons, and by 2019 it has reached double of the 1990 figure. So it has become, the carbon dioxide emission has reached 1 billion tons. So we can see, like in this 30 years, 29 to 30 years, there is almost doubling of this carbon dioxide emission, because aircraft industry started witnessing growth. Now, after 2019, we can see year by year what has been the contribution towards carbon dioxide emission year by aviation sector. 2019, it was 1 billion ton, 1,000 million tons. By 2020, dropped down because of the pandemic, because there were travel restrictions. It almost reached half. From 2021, it was slowly picking up, and we have reached at 2025. We stand where the emission is almost nearing the pre-pandemic levels. So again, aviation has picked up, travel has picked up, and the carbon dioxide emission has grown to pre-pandemic levels, and it is going to go very high exponentially. You can see by 2040, it can even reach 1,500 million tons. That is 1.5 billion. It can triple from compared to 2019 figure, like 1990 figure. It was 0.5 billion tons, and it is expected to triple by 2040. So if it is expected to triple only if we don't engage in any sustainable practices. But if we engage in sustainable practices, yes, it can, by 2050, it can definitely come down to this 2020 level, that is during pandemic era. It will definitely come down. So here is where the scale, you can see the scale, how the growth of emission, what is the growth of emission by aviation alone, and what is the importance of sustainability in aviation. And this is we just checked the quantifiable version of this aviation, this emission. Now let us see what is the share of global carbon dioxide emission. How much is the aviation sharing in terms of percentage? Again, 1940 figure, if you take, it was less than 0.5. And as we reached 2019, 2020, we almost reached 2.5% of total global emission. Again, it dropped down because of Corona, thanks to Corona, we should say, and slowly we are picking up. So the emission from 1914 to 60, 70, 80 years, see how much growth has happened in airline industry, aviation industry, and what is its contribution for the global aviation. Now, there are three matrices. How do we calculate the carbon emission from aviation? There are three matrices. One is the aviation demand, like what are the demand for passenger as well as the freight. What is the energy efficiency or the energy used, we can say, and the carbon intensity. These three, when we multiply all the three matrices together, we get the carbon emission from aviation. So let us see one by one, all the matrices one by one. Aviation demand, it represents the total passengers and the total freight kilometers, like how many passengers travel and what is the cargo freight cargo transport happened in terms of kilometers. Now, as we have already seen, between 1990 to 2019, the passenger demand and the freight demand has approximately quadrupled. It's increased 4 times. And more people are flying, more stuff is being moved around. So that's very evident. Like people are opting for flight travel more and more. So here we can see that in between 1990 to 2019, the travel has increased 4 times. Now let us see what is energy used. What is the impact on energy used? Energy efficiency, we know it's the energy required per passenger kilometer. How efficient the fuel is. Traveling 1 passenger kilometer in 1990, it used to take 2.9 megajoules of energy. And by 2019, this 2.9 megajoules of energy has reduced less than half. It has come down to 1.3 megajoules. So we can say that flying has definitely become more energy efficient because of the improved designs and technologies and larger planes and more passenger load factor. Passenger load factor in the sense like there are less empty seats compared to previous flights, because once I remember in 2006, I think around 2006, when I was traveling from Bangalore to Chennai, the flight was hardly occupied by 15 passengers. The capacity of the flight was 72, but hardly it was occupied by 15 passengers. So the passenger load factor was very less at that time. But nowadays, unless all seats are filled, generally they don't take off. They don't, take off. So passenger load factors have improved. That is one of the factors. Improved design is another factor. Technology is improving and larger planes are coming to market, which is improving the energy efficiency. So we can say that energy efficiency in this period, 1990 to 2019, the energy efficiency has doubled, or the energy used per kilometer has halved. So that is another metric. And the third metric is carbon intensity. So carbon intensity measures how much carbon dioxide is emitted per unit of output. For example, if we take revenue passenger kilometer is nothing else but the total number of passengers traveling, total number of kilometers. So multiply both, you'll get passenger kilometer. Revenue passenger kilometer indicates the people who are paying for that flight. So this is a metric generally used in aviation. One of the metrics is generally used in aviation industry. So if we go try to understand what is carbon intensity in terms of revenue passenger kilometer, it's like how much carbon dioxide is emitted per revenue passenger kilometer. So it has not changed considerably. Why? Because the same fuel what was being used in 1990, we are using it. The same jet fuel only is being used. So the carbon intensity is the same amount of carbon dioxide is getting emitted. So carbon intensity almost remains the same. Alternate fuels are there. Yes, SAF has come into market, but still it is very less, a tiny fraction. So when we multiply all the three, we understand that, as I told, this aviation demand has quadrupled, energy efficiency has increased twice. So we can say that in total, carbon intensity remains the same. So in total, the effect is there's a doubling of carbon emission. That's what we have seen in the previous graph. So that's why now we understand why aviation sector is important, why we need to consider aviation in sustainability, taking globally, taking sustainability measures. So aviation is the critical transportation sector because, and for global connectivity. Now in India, Prime Minister has launched Sudan scheme a few years back, like to increase the connectivity, to increase even the rural connectivity also, as a suburban connectivity. So as the connectivity increases, aviation, the number of passenger increases, energy consumption increases, and pollution increases. So there's a matrix which says that in 2025, the passenger of revenue passenger kilometer (RPK), it is expected to grow by 8%. So it is going to reach 5.2 billion passengers. It means it is the first time in this year it is going to cross 5 billion passengers this year. So that's the way aviation sector is growing. Now, in terms of passenger volume prediction, so how much passenger will be flying? Yes, 2019 saw 4.5 billion passengers. Again, there's a drastic drop because of travel restrictions due to Corona. Again, we have reached that level, the pre-pandemic level in 2024. And by 2025, again, as I told, it is going to reach 5.2 billion. And in 2040, 2050, there's a considerable increase. It is going 4 times high compared to 2025. Like it's estimated that by 2050, 25 billion passengers will be using airlines. Okay, so this was the brief information about like why aviation sector should be considered, put under radar and should be considered at the fastest possible rate under sustainability measures. So now what are the global sustainability targets? Global sustainability target, one is the net zero 2050 commitment. Net zero commitment, this, as you know, it was adopted in Paris Agreement in 2015 that even by 2050, the complete global industry, every industry should work for attaining net zero emission. What is net zero emission? That whatever is emitted, whatever gases are emitted, whether it is carbon dioxide or GHGs, it should be taken away from the atmosphere. That much quantity should be taken away from the atmosphere simultaneously, so that the effect is net zero on the environment. So this commitment, like the target set is 2050, and this has been agreed by even aviation industry. ICAO has also agreed, and ICAO has set roadmaps for achieving this emission targets, like sustainability target of net zero. Now, this was again, though it was set in 2015, this was again reinforced in 2022 October by the 41st Assembly of International Civil Aviation Organization. Now, speaking about net zero target of India. India has set a net zero target of 2070, achieving it in 2070. And China and Russia aim to achieve this net carbon neutrality by 2060. India needs more time because the population is rising. It's a developing economy. More energy is not only developing economy. The energy sector is aviation is rising because India, if you see, aviation is the third largest, going to be taking over as the third largest aviation industry in the world. So every sector sees growth. So India needs more energy. So it cannot work towards achieving 2050. So PM had recently announced that 2070 is our target. Coming to China and Russia, yes, they are also, China is also again developing economy. They have set their target as 2060 and Russia also as 2060. Rest of the developed countries are working towards achieving 2050 as carbon neutral year. Now, what is IATA's Flying Net Zero Initiative? International Air Transport Association, as I had already mentioned. IATA has launched a Fly Net Zero initiative even in line with this global commitment of 2050, and it has even given a roadmap how to achieve this target. Though it is like we can't say by 2050 aviation industry can achieve this, but yes, roadmap is ready and we have to work for it. For this achieving this particular result. Now, what are the various strategies? Various strategies to achieve this? What in the roadmap they have mentioned that yes, improving fuel efficiency, shifting to SAF, sustainable aviation fuel, investing in innovative technologies, and enhancing operational efficiencies. So these are the steps. What we will discuss it in detail in the coming slides. So these are the steps which has been gaining focus in this IATA's roadmap. Now, this requires coordinated effort across the industry, across the world, we can see. Now, what are the global sustainability targets? Global sustainability strategies, sorry. So we saw the targets already, the strategies. Now, what strategies will be implemented and how? So first one which is gaining more importance is the sustainable aviation fuel. Yes, because the jet fuel what we use, it is very carbon intensive. We have already seen. So first one, we need to focus on changing this jet fuel to something more sustainable. So sustainable aviation fuel is a low carbon fuel, and it is estimated that it will contribute around 50 to 80% of the emission reductions needed for the aviation. It is estimated that this is going to drastically change the reductions, the pollution contribution from the aviation industry if we adopt it as soon as possible. And again, this is there are challenges in SSF. We'll see what it is. First of all, let us see what are sustainable aviation fuels. Sustainable aviation fuels are produced from biomass feedstock as well as non-biomass feedstock. Feedstock is nothing else but the input material what goes into making this aviation fuel. This biomass feedstock can be waste oils and fats. Like waste oil in the sense even used cooking oil can be used, considered as a feedstock. And then we have animal fats, agricultural residues like straw and corn stover, forestry residues, wood chips, sawdust, etc. Even dedicated energy crops, even microalgae. Microalgae is under R&D because they can store lots of lipid, lots of fat in the body. So, and they need less space compared to any other biomass feedstock. Microalgae needs less space, less land. So this is under R&D, and if this hits, then definitely it is going to be a boon to aviation industry for using the sustainable aviation fuel. Now coming to the non-biomass feedstock includes the municipal solid waste like cardboards, whatever organic material. It can be organic material or it can be like paper or cardboard what we throw off. This can be used as an feedstock for this sustainable aviation fuel. And there is power to liquid process, another methodology which is also gaining importance. It is a method where we produce synthetic fuels. It's like e-fuel. It's also called e-fuel by using renewable electricity, water, and captured carbon dioxide. So water is split by electrolysis. Water is split into hydrogen and oxygen. This hydrogen and this captured carbon dioxide are used to produce hydrocarbon, which can be later converted into fuel. So now the question is, yes, sustainable aviation fuel is gaining importance, but can we use it as such? Or do we need to do any modifications? So as of now, as per ASTM allowance, like American Society for Testing and Materials, they have told that we can blend 50% of SAF with the existing jet fuel, and there is no problem. We can use it in the current condition, current aircraft and engine conditions. It can be used. So there are no major modification required on in the engines of the aircraft. It's a drop-in fuel. That's why it is called a drop-in fuel. It can be used with 50% blending, and it can work seamlessly without any problem. But when it comes to the infrastructure in the sense it has fuel lines, storage system, refueling vehicles, etc. These all are compatible with the SAF blend. Like these are the facilities required to fill the aircraft with fuel. So pipelines, storage systems, and refilling vehicles. This can also be this is also compatible and can be used as such. So currently the allowance is given only to 50% blending, and R&Ds are happening to use 100% SAF in the existing aircraft, as well as development of new aircraft which can solely work on SAF. So now what is the current usage of SAF? As I told you, it is we can blend up to 50% with the conventional jet fuel. We can theoretically we can use it in much higher concentration, but now as per the permission given by ASTM, we are using it. The industry is using it at 50% blending rate. Now, currently the SAF production is very less. It's like only 3%, 0.3% of the global aviation fuel consumption. Suppose in 2024, our demand for this global fuel was 300 billion liters, whereas in the production of SAF was only 900 million liters. So it was covering only 0.3% of the global aviation fuel consumption. So production rate is very low because it is highly finance intrinsic, as well as the production the land required. It requires lots of land because it uses biomass. So there are so many constraints. We'll see one by one what are those constraints in the coming slide. Now this is a production target for SAF, sustainable aviation fuel. Like European Union, it's already developed countries target, US and Europe. So in 2025 this year, they want to use 2% of the total aviation demand by SAF. Similarly, by 2030, United States want to produce 3 billion gallons of SAF. So these are some statistics like how they are scaling up their production. By 2050, US wants to reach 35 billion gallons, but we have to know one more thing, like they are giving 3 billion, 35 billions and all, but the amount of fuel that will be consumed is also considerably going high. So this may not be sufficient as we reach 2050 or 2060 and all. But still, these are the targets set for SAF. And when it comes to global aviation, by 2050, we are aiming for, as you know, it is net zero carbon emissions, and SAF has a very important role to play in global aviation. So all aircraft manufacturers, how they are supporting SAF, the use of SAF. So major manufacturers, as we know, they are Boeing and Airbus. Most of the flights are either Boeing or Airbus. So Boeing has already committed that they will be delivering aircraft which are capable of running in 100% SAF by 2030. Because currently, though, as I already told, we don't need much changes in the current infrastructure, aircraft engines or propulsion systems. But still, the fuel is different. The combustion, the properties are physical and chemical properties are different. So aircraft manufacturers are trying to adapt to SAF alone and produce aircraft which can solely work on these sustainable fuels. And by 2030, Boeing has committed they will be able to deliver these aircraft which run on 100% SAF. Similarly, Airbus have already conducted test flights using 100% SAF, and they are also working for attaining this sustainability across their fleet. Now, same thing is the Embraer. Embraer is also developing technologies for SAF compatibility, and they're also trying for hybrid electric aircraft. So what are the challenges in SAF? The first challenge is like the cost, high cost. The production cost is very high. It's limited in availability. As I told you, only 0.3% is getting produced when the demand is very high. Only 0.3% of the total demand is getting produced annually. So obviously the cost will go high, and currently the cost of SAF is 2 to 5 times more expensive than the conventional jet fuel. And this is because of the limited production capacity, as well as the feedstock cost. The feedstock, as we told, biomass feedstock or non-biomass feedstock, the production of those feedstock, the cost is very high. So these two are adding up to the cost of high cost of SAF. Now, also the limited feedstock availability. The sustainable feedstock available, like cooking oil, waste cooking oil, or used cooking oil or waste biomass, it's not available always in the same quantity. And if we want to grow this feedstock, you can imagine the amount of land required. It can even compete with our agricultural land. Or there is one more worry, like environmentalists generally worry about it. They are nervous that if SAF gains importance, even deforestation can happen. They can cut trees to plant these feedstocks for biomass feedstock for aviation. So another worry that comes to these people are like it can pave way for deforestation also. So this is a concern. Land use can change, like what is being used for agriculture can change to developing this feedstock also. Now, another challenge is we have to this criteria to be met. Like these feedstock, though, because the production has to be substantially increased, the land usage is going to increase, and as the land usage increases, it should not compete with agricultural production, like food production. If it competes with food production, we know what is going to happen. So that is another challenge. And another challenge is the infrastructure and scaling. The infrastructure and scaling, in the sense, completely like the companies are not have not set up the complete infrastructure for producing to a large extent of SAF. And the scaling, the production facilities are limited, and scaling up requires investment, huge investment and infrastructure development. The investment, again, the funding, which is again a challenge for the developing nations, it's a big challenge. And as I already had mentioned at the start, like developing countries had asked for $1.3 trillion last year in COP29, whereas the developed countries agreed only for $300 billion. Because as per SCF, the Standing Committee of Finance, they expect that the finance, as per the NDCs, the nationally determined contributions submitted by the different countries, they have already told that by 2050, the requirement of this, by 2030, the requirement of this funding will be $5 trillion to $7 trillion. And where is this $300 billion standing in front of it? So nowhere. So finance is a big constraint when it comes to sustainability. Yes, carbon offsetting. This is CORSIA method adopted by aviation, international aviation. This has been developed by ICAO, International Civil Aviation Organization. It's a carbon offset method. It's a carbon offsetting and reduction scheme for international aviation to achieve net zero by 2050. This is applicable only to international aviation as of now. Why? Because 60-65% of emission is happening in international flights. So what is the methodology adopted in this? Like every airline should monitor their emission. They should report their emission, and they should verify their emission and take necessary steps to reduce it. And if and this CORSIA is set with respect to 2020 levels, that whatever was the emission in 2020, with respect to that only capping will be done. So capping is set to 2020 levels. So if any airline is increasing their emission with respect to 2020 level, then they have to go for buy carbon credits. Carbon credit is nothing else, but one carbon credit is equal to 1 metric ton of carbon. So they have to buy this carbon credit at a cost from companies or from agencies who are ready to sell it, who are using more renewable energy, and who are having carbon credit in stock. This can be done by afforestation or preserving forest or using more renewable energy, more green energy. So companies can stock carbon credits, and it can be sold. So aviation is a carbon intensive market, and obviously they need more carbon credit. So they need to look into this area. Now this scheme, CORSIA scheme is voluntary, set voluntary till 2027. But after 2027, it is supposed to be mandatory. Like every airline, every country has to abide by this. They have to go for capping their emission to 2020 levels, and buy carbon credits in case their emission is increasing. So that was the market-based measure, CORSIA. Now coming to aircraft-related technology, how it is going to help us in sustainability. So advanced propulsion system. Advanced propulsion system in the sense engines, like now hybrid electric, as I already told, hybrid electric engines are under R&D. Even fully electric propulsion systems are under R&D. So there are two companies, Hart Aerospace in Sweden and Volt Aero in France, which are working for hybrid models like hybrid electric engines. And Hart Aerospace has already demonstrated fully, a technology demonstrator has already been set up and they are already testing it. So once it is proved, definitely it can be a reality. And when it comes to fully electric propulsion system, it's again, it depends on so many things. Like it's not in near future we can achieve fully electric propulsion system. It should basically work in batteries, and batteries are like very difficult. You understand, like how while flying, how we can energize the aircraft, give thrust to the aircraft using batteries. It's going to be very difficult, but still efforts are on in this front also. Next thing is like lightweight materials. Yes, here composites are gaining advantage. Like if we reduce the weight, we know, like generally in the road sector and all, automobiles like Maruti, they reduce the weight of the car so that the mileage is more. And similar way, if the weight reduces, the efficiency also increases. So composites are getting used more and more. And if you see the latest Boeing 737 MAX or Airbus A350, Boeing has used almost 50% of the material as composite in their latest aircraft. And Airbus A350 XWB, which is the latest aircraft of Airbus, they have used 53% of composite materials. So as old aircrafts, generally they were using aluminium, mostly aluminium, with steel and some quantities of titanium. So when the phase out happens, the life cycle of an aircraft is almost 30 years. So when slowly the phase out happens, more and more composite aircrafts will be flying. And definitely this is going to add to the fuel efficiency. Now, engine efficiency improvement. Engine efficiency improvement, again, this is a target of 8% efficiency improvement by 2050. And for this, various measures are being taken, like geared turbofan engines are being used, or variable fan blade designs are there. Advanced materials are used for higher operating temperatures, and more efficient turbine and compression technologies. These are the methods used, being used. R&D is being done in this front also to achieve 8% efficiency improvement by 2050. Now, operational improvements. So that was aircraft related improvements. Now, when it comes to operational improvements, what and all are covered in aircraft operations? Aircraft operations include activities like on the ground. When the aircraft is on the ground, before passengers and cargoes are loaded, when the aircraft is taxiing to the runway or taxiing from the runway after landing, or when the aircraft is climbing, cruising, descent, or landing. So these are the various aircraft operations stages. And in the ground operations, before passengers and cargoes are loaded, there are multiple activities taking, like refueling is happening, cargo is getting handled, passenger baggages are getting handled, catering services like food supplies are happening. Food supplies in the sense they are just making necessary arrangements in the aircraft, and cleaning is happening, pre-flight inspection is happening, crew briefing is happening. So various aircraft operations that is happening before the aircraft takes off, before the passengers are loaded and cargoes are loaded onto the aircraft. So now we can improve. There are certain measures which we can bring in to improve these operations also. Let us see what are there, and these have been listed out by CAO again in the brochure. Like first one is like operating the aircraft. When aircraft is on the air, it should operate at the most economic altitude and speed. And again, the aircraft load factor as passenger. This is what I was mentioning in one of the previous slides. Like passenger load factor, it should be maximum. It should not fly. An aircraft should not even fly with even one seat empty. Now, next is loading the minimum fuel to safely complete the flight. So as the quantity of the fuel increases, obviously more fuel is needed to lift the aircraft and fly the aircraft. So if we keep it minimum, which is safe enough, then considerable reduction in fuel consumption will be seen. Next is minimizing the number of non-revenue flights. So what is non-revenue flights? Where the payment is not happening, which is like it may be ferrying aircraft, it may be training, it may be testing, anything. So minimize these number of non-revenue flights. This can also add up to, this is an operational improvement measure where emissions can be reduced. Now, I'm sorry for this. Taxing in the most effective way, taxing and flying in the most fuel efficient way. So you can say, like, while taxing, some of the aircraft generally use both the engines, but single engine can be resorted to when taxiing on the ground. And again, we can say that sometimes aircraft will be waiting at the gate for assignment. After landing, they may be waiting for gate assignment, or sometimes gate will be changed. So we can say not many delays when we are flying. So these things can be reduced, considerably reduced, when the airlines and the airport authorities work in collaboration. So, and even we can see, like, some aircraft will be hovering for almost 30 to 40 minutes. The total distance between destination and destination A and B will be for 30 minutes or 40 minutes. But again, after reaching the destination point, it will be hovering around the airport to get clearance to land. So this are wastage of fuel. So this can be avoided. So some operational improvements can be brought, and this can be avoided. So let us see where India stands in all these things. Like Indian aviation sector, if you see, it's contributing only less than 1% of the India's total emissions. So this is something good if you see. But the thing is that we cannot be happy about it. Why? Because the carbon emission from Indian aviation has considerably increased from 2012 to 2019. If you see, in the 7 years, there's a considerable increase of 64% in emission. So the first sentence what we read about, like India's aviation sector is contributing only 1%. Right now, it's nothing to be happy about, because it is definitely going to change in the coming years. India is going to overtake UK as the third largest air passenger market in this year. So again, there is a more fuel consumption going to happen, more emission going to happen. And yes, India is going to witness a doubling of air traffic, like by 2030. You see, in 2023, hardly 150 million passengers were flying, and by 2030, in next 5 years, 300 million passengers will be flying. So again, it is going to be carbon intensive. So now, growth in Indian aviation sector. The Indian aviation market was 12.58 billion in 2023 dollars in 2023, and it is expected to grow at a CAGR of 11.25. It's more than way more than our PF investments. You can see it is growing with a CAGR of 11.25, reaching a value of $26.54 billion by 2030. So you can see a significant increase in the market size, Indian markets, aviation market size. And Indian government has launched UDAN, which Ude Har Desh Ka Nagrik, Desh Ka Aam Nagrik. And this is instrumental in increasing air connectivity to smaller cities. So this, as UDAN scheme picks up, we can see more and more flying. And according to IATA, this India's GDP, this aviation sector is contributing 5% approximately to India's GDP, and it supports 8 million jobs. So this is a sector which is very much required for our growth also. So we cannot simply avoid it. We have to take sustainable action. It can aviation sector can contribute to $250 billion to India's GDP annually from this year. So this is a major sector in India which needs to be considered for sustainability, because it is growing in a significant manner. Now coming to airports operating on 100% green energy, as of December 2024, there are 80 airports in India which are operating on 100% green energy. The Airport Authority of India has prepared a roadmap to achieve 100% renewable energy for like how to achieve this 100% green energy sustainable airports. This roadmap has already been prepared by Airport Authority of India. And with respect to that, 80 airports have already achieved 100% green energy, and other airports are working towards it. So now, when it comes to carbon neutrality, in India, 4 airports have been declared as carbon neutral: Delhi, Bombay, Mumbai, Hyderabad, and Bangalore. So have been declared as carbon neutral. So, and they have been accredited with level 4 accreditation from ACI, Airport Council of India. So this means that around the globe, I think around 87 carbon neutral airports are there, and 4 are from India. So it's something we should be happy about. Now, again, in SAF blending, where do we stand? So we are very behind when it comes to SAF production, and currently our target is, Indian target is to blend 10% of SAF with a conventional jet fuel by 2030. And in the military front, you can see AN-32. It's a passenger transport aircraft in military. Air Force AN-32 has been certified, has been already certified. The fleet has been certified to operate on 10% blended fuel with aviation fuel. So, and when it comes to the production of sustainable fuel, Indian Oil Corporation, IOCL, has signed an MOU with Lanza Z US to explore how we can develop this SAF in India. So these are the developments happening in SAF production in India. And now, what are the challenges to sustainability in aviation? Yes, we have seen what are the strategies, what are the targets, and what are the climatic conditions prevailing, and how it is going to rise in coming future. And there are some challenges, like we need to achieve sustainability, yes, but still there are challenges. And what are the challenges? It's the high emissions. The emissions are going to rise. As the countries are developing, as the economies are surging high, the emissions are also going to grow. Now, as we have already seen, the aviation sector is accounting for 22.5% of global human-induced carbon dioxide emissions, but emissions have doubled since 1980s, 1990s. So we can see more emissions in coming future. And projection demand that air travel, we have already seen that air travel is going to increase, and it can even become 4 times compared to today by 2050. So emission is proportionately rising, it will rise. And second challenge is the production of SAF. SAF it gives us a very positive outlook when it comes to reduction, 50 to 80% reduction of emission from aviation industry. But still, it has its own limitations. It has its own production shortfalls that we have already discussed. The high cost, which is around 2 to 5%, 2 to 5 times high than the conventional fuel cost, and the feedstock competition, like feedstock, whether it should not compete with the land use. It should not compete with the agricultural feedstocks, agricultural crops. So these are the constraints from challenges from sustainable aviation fuel area. And there are other challenges in aviation, like sustainability in aviation, like technological barriers. Like, what are the technological barriers? As we discussed, the hydrogen and electric aircraft. Electric aircraft, as we told, it's like lower energy density, because once we use battery, it will not give us the output that we require. Per weight of battery, it will not give us the output that we require when we use the conventional fuel, because the output from a conventional per unit weight of conventional fuel will be definitely higher than the output we get from this use of batteries. So again, we need to see how far this is going to sustain. But yes, R&D is happening, and let us hope that we'll get a very positive output from this both hydrogen and electric aircraft projects that have been undertaken. Now, infrastructure need for SAF. This we have been discussing in the past few slides. Like, for production, for distribution, and from blending of SAF, we need a big infrastructure. And this infrastructure will call for investments. So again, here funding comes, funding requirements come, and the world is struggling for funds when it comes to sustainability and climate change, climate finance. So then there are regulatory and policy challenges. Like every country is developing their own regulatory challenges, and the global regulatory and policy challenges, policy is yet to come. In the sense, once a single policy rules the complete world, we can expect some better improvements in attaining sustainability. Okay, that was all about aviation sustainability. Now, a little bit I'll touch upon the ground support equipments and just to see what are the various areas which can contribute to sustainability in ground handling. So what is ground handling operations? We have seen like when the aircraft is handled, when the aircraft is handled, when the passengers are handled, when the cargo is handled, baggage is handled, all these are ground, and also the aircraft servicing in between flights and aircraft maintenance. So there are some equipments which will be used in all these scenarios like aircraft handling, passenger handling, cargo handling, baggage handling, and aircraft servicing in between flights and aircraft maintenance. So these equipments which are used for all these activities are generally termed as ground support equipments for the aircraft, ground handling equipment or ground support equipments. So generally, basically these are fueled by diesel or gasoline. But nowadays you can see certain GSEs are getting converted into electrical GSEs, and as on March last year, 2024, we can see almost 10% of the GSEs used in airports are electric. So GSEs are generally moving towards electrification when compared to any other source of alternate energy. Electrification is more seen in this ground handling areas. And global market is, as the aviation industry increases, aviation industry market increases, the GSE market is also considerably going to increase. And it is expected that by 2022, the GSE market is going to reach 17.44 billion. It means there's a huge scope of electrification in GSE market too. And the thing to note here is GSE emissions. Emissions from these ground operating vehicles which use diesels and gasoline, it's almost it's equal to 5 to 10% of the aviation emission from the aircraft. So this is again considerably high. So there's a large scope of improvement in GHGs also. Okay, so what are the various ground support equipments used? Yes, tow tractors and trucks. Tow tractors means where the aircraft is, the vehicles which are used to tow the aircraft. These are generally, we can see this, and when the aircrafts are parked near the gates, they will be towed using tractors, pushback tractors. They'll be like trucks or tractors. Why? Because engines cannot be operated there. It is not safe to operate engines near the gate areas. So generally it is towed using tow tractors. Not only that, it is fuel efficient. Burning jet fuel is more carbon intensive than burning diesel or gasoline. So generally, movement of aircraft on the ground is generally done by tow tractors and trucks, except it is when it is on the taxiway. Aircraft is on the taxiway. And then passenger stairs, yes. We have seen like when we board the aircraft from the apron and all, we can see this passenger stairs. It will be supported by a truck, and this truck will be diesel operated. Then boarding bridges. Boarding bridges, again, we can see when we directly enter from the airport to the aircraft, we will be using passenger boarding bridges or jet bridges. Then baggage carts. Like when we check in our baggages, at the backside, these baggages will be transported through carts to the aircraft. Now there are belt loaders. Belt loaders, yes, generally when we pick up the our luggages, we can see conveyor belts will be there. So these are again ground support equipment for the aviation industry. And there are cargo loaders. Cargo loaders are capable of accommodating huge cargos. So the requirement of fuel is also high, very high when it comes to cargo loaded trucks. Then there are ground power equipments, power units. This ground power unit means they are termed as GPUs, which power the aircraft when the aircraft is on ground. Like aircraft will not be working on the batteries, aircraft batteries or the engines. It will be working on the GPUs. GPU will provide power from the ground, and again, this consumes lots of energy. Again, aircraft air conditioning unit. When the aircraft is parked, ready for loading passengers, we can say like aircraft AC will be on, and this is not supplied from the internal like battery system or the fuel system of the aircraft. It is supplied by an air conditioning unit which is positioned outside. So again, that's a consumption of energy, more energy there. And then there are lavatory trucks, like in between flights, like once the flight lands, these trucks go and clean the lavatory. Again, this operates on gasoline engines or diesel engines. Then water service trucks are there, fuel trucks for refueling the aircraft, de-icing vehicles. De-icing vehicles basically are used where uh, temperatures are very low, where icing formation is probability is high. So de-icing will spray some chemicals where the icing is removed before the aircraft is taken off. So it will not wait for the aircraft energy to be used to de-ice the vehicle, de-ice the aircraft. It will be using a separate vehicle for that. Now, these are just few photographs of baggage handling. This you might have seen for ground handling equipments. Like this is a baggage handling trolley, where such trolleys will be moving our baggages to the aircraft or from the aircraft once it lands. And there's a refueling happening, like the refueling trucks will be refueling the aircraft in between flights. Then this is like aircraft getting towed from point A to point B. This is a tow truck. And this is aircraft maintenance when it happens in the hangars. There are various GHGs which are being used, which are again working on fossil fuel system. Then we can see here de-icing truck, which is removing the ice from the aircraft before takeoff. And this is a lavatory servicing truck, which is removing the wastage from the lavatory of the aircraft. So these are the few just examples, like GHG, GSs are available 100 in numbers per aircraft, actually per model of the aircraft. So again, as the number of aircrafts are more and number of types of aircrafts are more, the number of ground handling equipments are also more in every airport. So I just showed here very few which operates on fossil fuels. Yeah, so what is happening on the ground handling sustainability side? So electrification, as I told, electrification is a major move. And now, as of 2025, this year, the electric segment is projected to account for approximately 37.9 of the GSE market. Like whatever GSEs are being produced, 37.9, and 40% of the vehicle will be electric. That's the norms. And presently, if you see in the globe-wise, this globally, if you see the usage of electric GSEs, in Swissport, like in Switzerland, Swissport is using almost 44% of their GSEs is electric, and they want to increase it to 55% by the end of this year. Similarly, they want to completely transform into electric GSEs by 2027. So this airport is doing drastic changes in GSE front. That's why I posted this data here. So same can be taken as an example by various other airports also. Now in India, like if you see, our electric baggage trucks are taken over by electric baggage trucks. Electric passenger stairs are coming into picture. Belt loaders are electric now, and passenger ramps are electric now. So we are also resorting to electric GSEs in our airports. And yes, like if you see the conveyor belts and is working on electricity, and but still we need. There are lots of areas of improvement, and we need to take lots of action in GSA front in India also. Yes, now this is hydrogen powered GSE. This is emerging as a potential zero carbon solution for aviation also. And investment is also increasing, like in R&D of hydrogen. But the main challenge here is storing of hydrogen. Like it has to be stored in a sub-zero temperature, cryogenic temperature, like minus 253 and all. So it is a challenge to store this hydrogen in aviation sector especially. Or it can be in the liquefied form. If we store it in the liquefied form, we have to store it in minus 250 cryogenic temperature, minus 253 degrees Celsius. Or we can store it as a compressed gas also, but unfortunately the this one output from this compressed hydrogen will be less compared to like the conventional fuel. So this is a challenge with hydrogen powered GSC, but still there are across the world, across the globe, there are R&Ds happening in hydrogen powered GSCs also, like UK. Bristol Airport has already had done trials with hydrogen powered baggage tractors and some other GHGs also, and it has been successful. And again, in UK, one more airport, Exeter Airport, there are trials of hydrogen-powered GSEs, especially in the GPU. GPU is very much fuel-consuming your GSE. So especially in this area, they are trying hydrogen and also pushback tug. As pushback tug in the sense when the aircraft is getting pushed, when the aircraft is parked near the gate, aircraft does not have reverse gear, so it needs to be pushed back. And for this pushback tugs are used. It's an external tug which is used to push back the aircraft and position it on the taxiway. So on these fronts, hydrogen-powered solutions are being researched on, but it is not. It's not going to come in the near future. It's highly challenging actually. Now, then again, hybrid GSCs. Hybrid GSCs, yes, work is happening on this front, where electric cum gasoline powered or diesel powered vehicles will be used. So where electric power will be used, where low load usage are there. Like this is electricity, this will be supported by batteries actually. So where low load operation comes, electric power will be used. Where high load operation comes, diesel will be used. So this way, hybrid baggage trucks are have already come. Hybrid pushback tractors have already come, and this is operational in some airports. So for example, this John F. Kennedy Airport is using this hybrid GSC. So this is one area where we can definitely work upon. So this will have a large scope of fuel reduction. Then yes, there are solar powered. Solar powered again. This is we cannot use it in big units like GPU, ACU, and all. But small things like passenger boarding ramps and bridges, we can go for solar powered because the energy required will be less. So it can be sustained through solar. And this is, I think, this is already in use in UK and New Zealand and some countries, in US also. Another thing is leveraging data analytics and AI technology. It's like using real-time monitoring of GHA, GSS, coordinating between them, making them, using them, knowing when maintenance is required. All those things can be done if we employ AI technology, IoT things and all. So that will be very helpful. So that should be used in airports. But again, airports should be capable of implementing these technologies. Infrastructure development will be required, which will require funding again. So this is an example of a GPU. I just wanted to mention here because I wanted to show how much energy it is consuming. A diesel-powered GPU. This is in UK airport, Exeter Airport in UK. The one study was conducted, and it was shown that a diesel-powered GPU uses 78,000 liters of diesel fuel in a year, and it emits 200 tons of carbon dioxide. And when it comes to percentage emission from this particular airport, it is accounting to 39% of the ground handling equipment emissions. So you can see how much is this GPU consuming of fuel and how much it is emitting. So electric GPU is already in market, so it can how much drastic improvement it can make in emission reduction. Next, Yes, these are just a few examples. This is conventional tow tug, like which is used to tow the aircraft from point A to point B. Conventional tow tug are highly fuel. They use fuel consumption is too high in conventional tow tug, and yes, noise pollution is there, and their agility is less because they are connected to the aircraft through a tow bar. You can see a tow bar. This is they are connected to the aircraft through a tow bar, and because of that, the agility is less, and their weight is very high. They can weigh up to 10,000 kgs also, thus consuming more fuel. So now electric tow bar has come into picture. Many like Mototalk, TLD, they are manufacturing electric tow bar, the electric tow tugs, which is tow barless, which can directly take up this nose landing gear of the aircraft on its body, and it can move the aircraft wherever it wants. The fuel consumption is fossil fuel consumption is zero because it uses battery and rechargeable batteries, and noise pollution is again zero. It does not it's less than, I think it will come below 50 decibels, 50 to 80 decibels, and limited towing agility problem is sorted out because it can go and park in a very limited space also. And as the weight is hardly like when a tow bar less tow tug can weigh somewhere around 2000 to 3000 kgs. So you can see considerable increase, improvement in these technologies are coming up. And this is a tug which is manufactured by my company. It is under a prototype. And it was tested in Air Force. It was, the supplier, our customer is Air Force, and it was tested in one of the hangars in the airport. This is a testing photo. And the product first testing has been successful. Further improvements are underway. And this is the first prototype to be delivered, just not yet delivered, it's to be delivered, testing under progress. That's why I showed it in this particular slide. Just to show that many companies, this is a startup company where I work now, and many companies are working towards sustainability in whatever manner they can. So again, there are challenges for these green GSEs also. One is investment, as we have been discussing. Investment is substantial. Infrastructure like power grids, everything will be required when we resort to electric GSEs. And we need more and more innovations, like some creative innovations should come into picture. And when we do innovations, obviously when R&D efforts will be more, and it comes as a comes at a higher cost. So again, finance becomes a challenge here again. And then we require, like if we use electric vehicles, it works on batteries, and this should be eco-friendly manufacturing of these batteries. So again, after the batteries are worn out, again the recycling is very much important. This is again a challenge. The next is adopting hydrogen as a green energy solution, but their cost of production, their complexity in installation, and their maintenance, their storage, everything is a challenge when it comes to hydrogen as a green energy in aviation sector. Now, again, we have been talking about finance in if we need to have a sustainable change, we need finance. And finance is needed for developing countries. As we all know that the 100 years of industrialization, the past 100 years of industrialization has resulted in today's level of emission. And today we are facing do or die situation. So, and the benefit of this industrialization has been taken by the developed countries. Basically, there are almost around some 24 countries which have contributed, and so now the developing countries, they need their economic growth. They need to support their population. They need to grow. Their economic growth is a must because they cannot be always developing. So when the developing countries develop their technologies, they need more funding. They cannot divert their funding for their development, internal development towards sustainability. It is going to be very difficult. That's why there is a need that the developed countries who have polluted this, whose industrialization practices, rapid industrialization practices and wealth amassment has resulted in this level of pollution, they should hold hands to these developing countries. And there, it is there where climate finance come into picture. But unfortunately, the last SUP was not that effective in this front, in climate finance front. And again, finance is very critical when we adopt a cleaner alternative. One more thing is like the upfront cost of renewable energy are much higher. Like any renewable energy, the first initial cost is going to be very high, where we need lots of any startup or anyone going to start this, except unless it is a very large company, they need a fund, and it should be supported by the government through subsidies or some other means. Now, new innovation, as I told, innovation should come into this sector. And as new innovation comes, R&D cost is going to be very high. And this R&D risk of failure is why? Because risk of failure is also high. So, and the front runners of these technologies, new innovations have to bear this cost again. So, funding is required in that area also. So, and new technologies, if we buy from developed countries, again, we require funds. So wherever you turn, it's a funding. Funding is a major challenge, you can see, though everything leads to funding. And as I had mentioned, the SCF, the Standing Committee of Finance, it's a UN body, it has estimated that the annual financial needs of sustainability, climate finance, is around $450 billion to $584 billion. And what has been agreed in CQG, last new collective quantified goal, it's 300 billion, that $300 billion. This is like developed countries have agreed only to give $300 billion per year from the 2035, which is nowhere, it is hardly, it covers only about half the needs of 98 developing countries. So this is where we understand that yes, finance is going to be a big challenge in sustainability. So coming to conclusion slide, yes, aviation is one of the hardest sector to decarbonize, and it's a growing sector. And we should know that like at any point of time, 10,000 planes are flying in the sky. So even if we can bring in a small change, the net effect is going to be very good. So it can contribute towards considerable reduction in emission. And yes, finally, yes, again and again, I'm telling climate finance has a major role to play. And yes, collaboration between various governments, various industries, and researchers is also must. With this, I stop my session today, and thanks for the patient listening. These are the references which I have referred for making this slide.
Question answers and questions. Any questions from the audience side, please?
Currently, the cost of SAF is 2 to 5 times the jet fuel cost because of high production rates and limited feedstock availability. High production cost and limited feedstock availability. Actually, SAF is, when compared with jet fuel, it is considered to be a better fuel. Performance-wise, it is right now it is giving at par with jet fuel only, because right now only 50% blending is allowed as per as ASTM. But companies like Boeing and Airbus, they are developing 100% aircraft which can work on 100% SAF, and definitely this is going to give us a much better impact or much better solution.
Any questions, Mo? Okay, thank you, ma'am, for this wonderful session. And your session has given the audience a deep understanding about various green energy systems or aircraft systems. Okay, once again, thank you, ma'am. Thank you.
Thank you, sir. Thank you very much.
Thank you.